Because tomorrow will be 7. All right, so number 1, ask you to do 3 things. It asks you to tell me the electronegativity difference. It asks you to tell me the bond type and which atom was more electronegative in the grouping. Okay, so you have 3 things to tell me. So I will give you all 3 answers to the question. So number 1, the difference is 0.4. The bond type is polar covalent. The more electronegative atom is I. B, the difference is 1.0. The bond type is polar covalent. The more electronegative atom is O. C, the difference is 2.0. The bond is ionic. The more electronegative atom is Br. D, the difference is 1.2. The bond is polar covalent. The more electronegative atom is chlorine. E, the difference is 1.9. It is ionic. The more electronegative atom is fluorine. F, the difference is 0.1. It is nonpolar covalent, and the more electronegative atom is sulfur. And G, it is 0.4. It is polar covalent, and the more electronegative atom is carbon.
What type of bond did you say E was?
E, I said, was ionic. Now, this one wants you to go in order, again, of most covalent character. So you're going from largest to smallest. So largest would be, all right, KBr, and then HF, SiCl, SO, and then you have 2 that have the exact same number. So you could either have written CH or HI next. They can be flipped. They're interchangeable. And then you have SES would be last.
So do you put a unit on electronegativity?
Nope. There's no unit.
The difference, you just put the number?
Mm-hmm. Correct.
And like, when you have a combination of metals, it's always metallic?
Yes.
So for it to be honest, you have to have both?
For,
non-metal and metal?
yes.
So the one that's more,
I'm just going to take a shot in the dark and guess you're not on a bus there. Yeah. You'll have detention tomorrow, dear. Say what?
The one that's more electronegative is the one that's closest to fluorine?
Is the one that's the closest to fluorine, yes. It's also the one with the bigger number on the chart. Yes. Anybody else? Question? No? We're ready? Yes, ma'am? Huh?
Can I get water?
Yes, you may. All right. You need a electronegativity table. And as long as you haven't written on it, you may use yours. If you've written on it, you need to borrow mine. You drew in just the stairs? No, as long as you just drew stairs on it, it's fine.
We're gonna get the orange one.
Why would you need the orange one? You have the orange one, but if you have the electronegativity table, I think it'd be the same. You just need the electronegativity numbers to subtract. Did you get ice cream for breakfast? Just brought it from last night or something? The champions there. Yes, you may. Aren't you supposed to be like eating healthy during the sports season or something? So, you know, you're prepared for games and all that. Or is this some kind of new diet for athletes? Okay.
Can we get a calculator? I don't
Yeah.
want.
Yes, by all means. If you're in Caroline's category and you've got to have a calculator, by all means. Maybe she should just hand y'all a calculator. It's true. It's true.
It does spell out like a whole word.
You may use the abbreviation. Sometimes ionic is nice if you write out the word instead of, but PC and NPC are fine. But metallic or ionic, sometimes I miss those letters if you're a messy person. All right, those of you who are charting today will serve detention Monday of next week, by the way. So you're going to have to remember. Put it in your phones and remind yourselves. So that was who? Lolly, Diamond, and Alex. So after the quiz, put it in your phone to remind yourself Monday when we come back from Thanksgiving. Here, I'll try to put a sticky note on my desk to remind you. Internet it is. Electronegativity chart. We will have detention the Monday we come back from Thanksgiving. Because they're not doing it tomorrow. And I've been making a list on my desk, so if I don't manage to lose the notes between now and then, I'll be able to remind you that Monday. All right, who's still working? I got two, because I can put the net in the back. So we're gonna throw them down to just a net. All right, now grab your stuff and there's a table in the back. And then just come back when you're done. All right, pass first to the front. All right. I actually wrote so small I had to look see for anything down. All right. If you will, you need your notes and a periodic table. It does not matter if it's the electronegativity table. I'm going to give you your electronegativity table.
Water.
Yep.
Are we gonna need these?
Not unless you can't. Well, hold on. Can you multiply and add? Got to add electrons. If you can't add electrons, yes. All right, so where did I stop Friday? I know I didn't finish the vocabulary. I said I had one more word to go. What word did I have left? What word did I do? We did bond energy. So the energy needed to break a bond. So we talked about there were 3 types of covalent bonds. What were they? Okay, did we talk about which bond was the strongest?
Yeah.
Which bond was the strongest? Triple bond. So it's going to be the hardest to break. Which bond is the easiest to break? Single bond. So we didn't talk about bond length. Okay. All right, so we got to finish bond length and then we're on to Lewis structures.
Yeah, sure.
All right, Lewis structures aren't bad. I don't think y'all will hate those today. All right, tomorrow you will dislike more than today. All right, so bond length. All right, now when I ask this, people always go, it's the length of a bond. No, it's not. All right, it's the average distance between 2 bonded atoms. Now, why is it the average distance? All right, it's the average distance because 2 atoms are always in motion. All right, so we take various measurements while the atoms move and average them. Okay? Because atoms are never still. Okay? I mentioned this at some point. We're going to talk about this again when we do the gas laws. All right? Atoms are never still. They're always in constant motion. And because they're always moving, you can't measure the distance definitively between one atom and another. Okay? So you have to take various measurements between them, and then you average those measurements to get a distance. All right? Now, you have to know the 3 types of motion. We're going to talk about this again with gas laws too. No. We will talk about that briefly with the gas laws also. All right. Atoms can translate, okay, which is called translational motion. All right, it's the only kind of motion this wall has for the most part. I move from point A to point B. When I walk from here to here, I translate. That's what most of us do. Some of you are more skilled than the rest of us, and you have the ability to rotate. Maybe you took gymnastics, and you have the ability to flip, okay? Some of you might be very skilled and be able to run and flip end over end. It's never a skill of mine. I was always afraid I was going to land on my head. Nope, no definitions. I think most of you will remember what those things mean. Now, Some of you probably know people who vibrate and have vibrational motion. Okay? They shake constantly. Typically, it's older people who do that, but sometimes younger people do. All right? They shake constantly.
Does that count?
Huh?
I do when I get cold.
Yes, people do when they get cold. Okay? But most often it's related to a medical condition. Most of us don't just vibrate naturally.
Like Parkinson's.
Like Parkinson's, yes. Okay? Vibrational motion. All atoms have vibrational motion. What are you laughing at over there?
Because like my nerves in my hand are bad, so like right after practicing I use it a lot. I try to calm my mind like this.
Yes, that would be vibrational motion. Okay? And it does happen that way a lot. Alright? If you watch me in physical therapy, particularly in earlier stages, mine would do that regularly. Still does if they maybe use too much weight. Alright? Now, questions about the types of motion. Now, because molecules are always moving, if you have two atoms that are vibrating constantly, can we measure the distance between them definitively if they're always doing this? No, you would have to measure them at various points and then take the measurements and average them. Okay? Now, which of them have the greatest length? So if we're talking about a single bond, a double bond, and a triple bond, who would be the longest of the three bonds?
Single. What?
The longest of the three bonds is the single bond.
It's the longest, but it's
That's right. I don't really feel like chopping my pencils in half, but
don't do that.
I use colored pencils. I got those by the dozens over here.
I give you one.
Why?
It's long.
Shortest one.
That's true. White, nobody likes white. All right. The longer they are, the easier they are to snap. Okay? Longer, the easier they are to snap. The shorter they are, the harder they are to snap. This is much easier before I broke my hand.
Yeah, don't.
I can't do it. I have no strength in my left hand. I can't do it. I can't even get the top off the vitamin bottle anymore. We had to break the lid for me. All right, so the longer something is, the weaker it is. So the shorter it is, the stronger it is. Okay? Does that make sense? Okay. The shorter it is, generally speaking, the stronger it's going to be. Now, stick it on my desk. Come back in. Questions about bond length. All right, now we're going to do Lewis structures. We're going to draw today. Now, when we draw, I strongly recommend pencil for those of you who like to write in pen, because we're going to erase dots. All right. We're going to do Lewis structures today. Now, first of all, what is a Lewis structure? Okay? It is just a picture of a molecule to represent where the electrons are shared in the bonds. Now, notice the word I used, shared. So, Lewis structures are only used for covalent bonding. Okay? We are not going to use these for ionic or metallic bonding. We can only use these for covalent. So after the Thanksgiving break, when we come back and we talk about ionic bonding, will we draw Lewis structures? No, because do they share electrons? No, Ionic bonds don't share electrons. Metallic bonds don't share electrons. So we can only draw Lewis structures for covalent bonding. Okay? Now, in order to draw Lewis structures, and the octet rule also applies to other stuff, but the octet rule, first of all, is not the Holy Grail. It's a nice jumping off point in a first year class. Let me say that again. It's a nice jumping off point in a first year class. Because y'all are an honors class, we're going to do things that do not obey the octet rule because it's a nice jumping off point.
But the exam has just the octet rule, right?
Say what?
The exam has just that rule, right?
Do you teach a non-honors class?
I have. We don't offer it anyone. Okay? All right. Compounds tend to form so they can share, gain, or lose electrons so they achieve 8 electrons in their outer shell. Okay? Compounds tend to lose, gain, or share electrons, so they achieve 8 electrons in their outer shell. Notice I use the word tend to form. Now, the reason I said that is, do they always form 8? No. Y'all are in an honors class, so we're going to branch out into some things that don't have 8, just because we can. Yes, we can. Okay, just because I want to drive Diamond and Caroline crazy.
If this is honors, I'd love to stay here with my AP. Oh, I don't think I can handle it.
It would probably put you over the edge.
So if I have a nervous breakdown, I can take the next day.
You wouldn't have a nervous breakdown, I promise.
So if she had, when she go to the doctor, they say cut out stress.
Okay, I'll drop out of school.
This isn't even in the ball. This isn't even in the ballpark at AP level people.
It is, it's.
You have to take it.
You could probably pay me to take
All right, we caught up?
I'll say good morning.
All right. Whoa. You said what?
It's called.
Okay, we.
Got it? All right. All right. So what do we have to do to draw these Lewis structures? All right. Number 1, you have to total the valence electrons. Okay, we got to count up and total the valence electrons. Number 2, and for some odd reason I call them outer shells when I teach it as the periodic table, and I call them valence electrons when I teach bonding. I have no idea why I do that, but I always have, so you'll figure it out. All right, number 2. Determine the central atom. There's 2 rules you can use. All right. The element that is a single atom is usually the one that's the central atom. So for example, if you have CH4, SO3, Ni3, the central atom is going to be the one that's the single. So if you have C, S, N, those are all single atoms. Okay, they're going to be the central atom. But will we always have something that's the single atom? The answer is no. So you can also say the element farthest left on the periodic table, but who's the exception? Who can never be the central atom? That's right, except hydrogen. So if you have something like NOCl, for example, all right, if you look at the periodic table, you'd have to look at the positions of NO and Cl and see who's furthest left out of those choices. All right, and nitrogen is farther left out of those choices, so N would be your central atom.
Will you ever have all those in the same group?
It's in the same group. I don't think so. I don't think they would do that to you. I would not do that to you. I'm pretty sure the state would not do that to you, okay? That would really be edging into AP, and I would not do that to you, okay? It's sort of like when we were doing ionic radii, and I made sure they were all in the same group, and they all said +2, okay? I could have given you an isoelectronic series, and that's really edging into AP also, okay? I'm trying to be kind here. All right. Place all remaining atoms around, not in a line, around the central atom. All right. Place all remaining atoms around the central atom. It's not. Okay? Everybody got that one? Because now we got to talk about these electrons. That's the hard part. And I'm going to do it on the next board so that it doesn't get real tiny. All right, everybody there? All right, so step 4. Put the valence electrons from step 1 on each element until everyone has 8 electrons. If any elements come up short, you must rearrange the electrons until they all have 8. Now, there's one exception that I'm going to put here right now. The exception that I'm going to put here right now is hydrogen. And I'll do an example with that one shortly. Okay, so you have electrons. Let's just say you added up 32. When you put in the 32 electrons, everyone must have 8. If everybody doesn't have 8, you have to rearrange until they have 8. Now, we're going to start easy. Everybody's going to have 8 initially until you figure out how to draw Lewis structures. This rearrange until they have 8 is where the multiple bonds comes from. Okay? So the multiple bonds. What are multiple bonds?
3.
That would be your double bonds and your triple bonds.
Oh.
That's where we're building towards the end of class.
Wait, I thought the valence electrons only have 8. That was the mass.
Yes, but when you draw them in, some of your elements are not going to have 8. You're going to be short electrons. So you're going to have to rearrange the electrons so that everybody gets 8. Because in nature, elements share electrons so that everybody gets 8. That's where the double and the triple bonds come
So,
from.
like, when we have a single bond, we'll have at least 8, a double at least 16, and a triple at least 21.
Yes, that's where that's going to come from. Okay? All right, does everybody have the steps written down so we can talk about how it works? Yes? All right, let's start easy. All right, so let's draw CCl4. This is as easy as it gets. All right, CCl4. All right, so we want to add up the electrons. This is just like adding up a mass, except we're adding up electrons. All right, how many elements do we have here? All right, what are their names? All right. So instead of looking up masses, this time we're finding electrons. So how many valence or outer shell electrons does carbon have? How many does chlorine have? I didn't mean to stump y'all. All right, now, we're dead in the water if every person in this room does not know where those numbers came from. So do we all know where those numbers came from? Since some of you people are shy and will not say, well, I don't know where that number came from. 1, 2, 3, 4, 5, 6, 7, 8. Carbon is in group 14. Chlorine is in group 17. So if I'm in group 14, I have how many outer shell electrons? 4. If I'm in group 17, I have how many outer shell electrons? 7. Does everybody see where we got those electrons?
Yeah.
Okay. How many carbons do I have in the formula? So times 1. How many chlorines do I have?
4.
The only thing that's different is we're not looking up an atomic mass. We're looking up the number of outer shell electrons. So 1 times 4 is? 7 times 4 is? So we add it up and we get what? All right, this is our valence electrons. That's step 1. Okay, so when we draw our Lewis structure, we're going to have how many dots? 32. Okay, oh my God, it's a lot of dots. All right, now, it's an easy one. Okay, so step 2, determine the central atom. All right, the element is by itself. It's a single. It's going to be the central atom. So do I have one that's a single? That's the central atom. Okay? And then place all the remaining atoms around the central atom. Not in a row, but around the central atom. So, how many CLs do I have? I got 4. So, I'm putting 4 chlorines around my carbon. 1, 2, 3, 4. If it had said 3, I'd have only drawn how many chlorines? 3. If it had said Cl2, I'd have only drawn how many chlorines? If this had said 2, I'd have only drawn how many chlorines? 2. Whatever that number is tells me how many of these things to draw, right? If it had said Cl5, I'd have drawn how many chlorines? 5.
But I thought we were the dots.
That's next. Step 4 is the dots. We're not there yet.
Yeah, okay.
Step 2 said to find what? Find the central atom. What was the central atom? Carbon. So I put it in the middle. Step 3 says place all the remaining atoms around it. How many chlorines did it say I had in my formula? So that's why I drew 4 chlorines. Does everybody understand why I drew 4? Okay? That's next. Okay? So I'm drawing how many dots? 32. Now, I start on the central atom. Technically, it doesn't matter where you start. I just start on the central atom. Pencil, people. I'm going to be erasing in a minute. You might even want to wait.
Okay.
All right. So I drew 8 of my 32 on my central atom. Okay. 2, 4, 6, 8 are on my carbon. Now, my carbon's full. So where am I going now? All right. So there's 8, 10, 12, 14. That's full. 16, 18, 20, 24, 26, 28. I'm off, I'm counting wrong. That's 28. That's 30. That's 32.
Wait,
All right.
but how did you not draw the dots, like, on
Because
the...
they share.
Okay. Now, 2, 4, 6, 8. Does this chlorine have 8?
Yes.
Okay. This chlorine. 2, 4, 6, 8. Does that have 8?
Yeah.
2, 4, 6, 8. Does it have 8?
Yeah.
2, 4, 6, 8. Does it have 8?
Yes.
2, 4, 6, 8. Does my carbon have 8? All right, let me go back and recount, make sure I have 32. 2, 4, 6, 8, 10, 12. Jeez Louise, I hit that extend page. I didn't want to do that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I have 32 dots, right?
Yes.
I drew in all 32. Everybody has 8. Now, what's happening here between the Cl and the C? When they share, we draw lines. We draw lines. That's a Lewis structure. Now, I'm not going to draw dots there again because you guys are smart enough to know that between the C and the Cl, you can just draw a line because you're going to know their lines. Okay? You can draw now.
But it only has 24.
No, it doesn't. Because the line is how many?
2.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Each line is 2. And then we need to talk about what the vocabulary is that goes with the lines and the dots. Not an option. All right. The dots. The dots are called lone pairs, which is the term you will hear me call them most often. We can also call them non-bonding or unshared pairs. It means there are electrons not involved in the bond. They will be very important tomorrow with geometries. Okay? They're called lone pairs, non-bonding pairs, or unshared pairs. They're the electrons not involved in the bond. They are incredibly important tomorrow. The lines are called bonding or shared pairs. They're the electrons involved in the bond. Okay? But the lone pairs tomorrow will be very important for the geometries. All right, everybody got it? See a nodding head going no. All right, let's draw water. After a long one, we need a short one. All right, how many atoms we got? Two. What are they? Okay. How many electrons in H's outer shell? One. How many in O's? Okay. How many hydrogens up here? How many oxygens? So we get 2, we get 6 for a grand total of 8 electrons. All right, I downsized you. That's a whole lot less dots, isn't it? Lolly took lessons from you over there. Almaja, she's eating the breakfast of champions too. All right. How many elements do we have to pick from? 2, so who do you think is the central atom? Yeah. All right, so O's in the center. How many H's are we drawing? Okay, you can either draw them like this, 2 H's, like that, and make them linear. Some people like to put 1 H on the top and make it more L-shaped. Doesn't matter to me which way you do it. This wall is not very creative. I'm sort of a linear kind of guy. So I tend to draw them in a line. You can do it any way you want. All right, so we need to draw in 8 electrons. Okay, now when I draw them, I do not draw the dots because I know that what's going to happen between the H and the O. They're going to share. They're going to share. So how many electrons does each line represent? 2. So I've already drawn in how many here?
4.
There's 4. Already taken care of. Now, H is an exception. H only gets 2 electrons. It never has dots or multiple bonds. The reason for that is, Antoinette was always mad at me because I never give her this electron configuration. All right, hydrogen only has 1s1. How many electrons can go in an S sublevel? That's it. That's all it can have is 2 electrons, right? 2. So if it can only have 2, those 2 are that line. That's it. That's all it can ever have. It can't have dots. So where are we going to put the other dots? On the O. So the 4 that we have left over go here and here. Does O have its 4 or its 8? Yes. Does H have its 2? It's done.
Can we just memorize that one? So I know which one to do it?
I'm telling you, H only has 2 dots. I mean, it's those right there. That's all it ever gets, that line. It's never going to have extra dots.
So if we had HCl,
So if you had HCl, H has how many electrons? Cl has how many electrons? How many H's are up here? How many Cl's are up here? So you got 1, you got 7. That's a grand total of 8, right? Now, this is one that has no central atom, okay? Because you only have 2 atoms. There's no central atom. So you just write those side by side. So H and Cl are just side by side. All right? So what do you know is going to happen to the electrons between H and Cl? They're going to share, so you're going to draw a line between them. All right, so what did we just say about H? It has no dots, no extra stuff, so those 2 are the 2 it gets. So where are the other 6 going to have to go? Around Cl. Does chlorine have its 8? Yes. Does H have its 2?
Yeah.
It's done. I'm going to give you one on your own. Going to give you several on your own. You think you're ready to try one? What do you mean no? You're not ready for a quiz yet. Because the quiz will have geometry, polarity, and Lewis structures. You're not there yet. All right, let's do H2S, NCl3, SiBr4. Here, there's 3 easy ones. Just like we did. That should be nice and easy. Nice and easy.
Okay.
It makes Anthony feel good. Hello, ladies.
What's up?
Not much. Y'all done? How about now? There?
Yeah.
All right, so how many electrons in H2S? 8. So what's the central atom? How many H's do we draw? And 8 electrons would be 2, 4, 6, 8. Now, does it have to be straight like that? No, you can have it in an L shape up, L shape down. It doesn't matter as long as you have 2 H's and 8 electrons like that. All right, and Cl3. How many electrons did you get? 26. Who's the central atom? N. All right, how many chlorines did you draw? And again, your Cl could be on top. Doesn't matter. All right, so we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Questions? Does yours look like that? Okay. And the last one, what did you come up with for electrons? 32. Central atom is? Si. How many BRs? 1, 2, 3, 4. How many electrons? You said were 32. So 2, 4, 6, 8, 9, 10, 11, 12, 16, 18, 20, 22, 24. There we go, 32. All right, so when we look, does yours look like that? Yes. So Lewis structures are easy, aren't they? All right, let's talk about multiple bonds. All right, so multiple bonds are double and triple bonds. Now, this is where this part of our steps come from. If any elements come up short, meaning everybody didn't have 8, did you have any that didn't have 8 in the 3 you just drew, other than hydrogen? No, everybody miraculously had 8. Now, the ones we're getting ready to do are, is everybody going to have 8? No, I'm intentionally going to give us some that everybody does not have 8. So, carbon dioxide. Same process. Nothing's going to be different. How many C's do we have? How many O's do we have? All right. How many electrons are in the outer shell of carbon? How many electrons are in the outer shell of oxygen? So when we add this up, we get 4, we get 12, for a grand total of 16 electrons. Who is our central atom? Carbon. Who is, or I should say, how many O's do we have? 2. Now, we're drawing in 16 electrons. So 2, 4. I always draw mine on the central atom, so I'm still going to do that. 2, 4, 6, 8. And I have 8 to go. Do you want to do 4 and 4 or 6 and 2? 4 and 4. All right. And those of you who wanted 6 and 2, I'll come back and do it that way too. All right. So I drew in my 16 electrons. Does everyone have 8? No. Okay. This is a problem. Some of you will leave it like this for me on the quiz and the test, and I'll just mark it wrong and keep on getting it. Big X and keep going. Okay? Because what did we say? They all have to have 8. You have to rearrange the electrons. Now, some of you are going to do this. Let me pick another color up here. Y'all going to do this to give everybody 8. Okay? Now, the problem with this is you said there are how many electrons? That's got 20. You can't draw in more electrons. Can't just slap up 20 electrons and go, I got 8 in this wall. Everybody's got 8 up there. Yeah, they do. But you can't draw in 20. You added it up and said there were only 16. Okay? So you can't put in 20. Okay? You have to move and rearrange the 16 you have. Okay? 8 has to be on every single one. That's correct. With the 16 you have here. Okay? Huh? Now, right here, the electrons share. Right here, the electrons share. So our goal is to allow oxygen and carbon to share the electrons with each other. Now, we can certainly move some electrons here to there, but are they sharing? No, because now O has 2, 4, 6, 8, and carbon only has 2, 4, 6. So that didn't benefit anybody for me to do that. Okay, so if I put them back, C has 2, 4, 6, 8. Carbon or oxygen only has 2, 4, 6. So moving them from that spot to that spot doesn't help anybody, right? But let's say I take it from right here and I put them right here. Now, what have I done? Okay, they're here. Okay, I still have 2, 4, 6, 8, 10, 12, 14, 16. Still have my original 16. They're only on C here. If I move them here, they would be where? They'd be on O and they'd be on C, right? So I'm going to take these electrons from here and I'm going to put them here so they can share between the O and the C. Now I'm going to take these and help out this O. So I'm going to take these and I'm going to put them there and help out that O. Now, I still have 16 because I have 2, 4, 6, 8, 10, 12, 14, 16. I still have the 16 I drew in. But now when I count, I have 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Everybody has 8 on the atom. It's just a drawing to represent what happens in nature.
I really thought. I know.
Lewis.
It's like saying
Y'all can punch him later.
you just tried to That's what you missed out.
All right, let's say that we didn't go with Devontae's vote, and I drew in my original 8, and you were somebody who voted put 6 and 2, Ms. Wall, and we did it this way. All right, these two have 8, but this poor guy down here only has how many? He's only got 4. Can we make it work there? Sure we can. How can we make it work down here?
When you the either the top or the bottom dots from C.
Okay, if I move them there and put them there, now O has how many?
8.
He's got 6, but he needs 8. What am I going to do? He's got to have more. Put the top there, where? Does he have 8 now? Do I still have 16? 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 16, and everybody has 8. These things are called resonance. Yes. They're called resonance forms. Both of them are correct. Do you have to know it? Yes. No. Don't want it. You'll be fine. Never see it again. It's sarcasm.
You said you're real.
The chances you will see it again are high. No, it will not be on the quiz. It will be on the test. No, there's a lot of opportunity in 78 questions.
It's all multiple choice.
We only get one class period.
Oh. How much of it is multiple choice?
51.
But what
is the other?
Free response.
I mean, what is it?
What you're telling me is-
Like,
This is the biggest bulk of the free response. Bonding is free response. Periodic table stuff is multiple choice. All right.
You said it's 70.
78 questions.
Resident is.
Resident.
We able to get up, like, extra top we say after or something?
Oh my God.
All right, polyatomic ions. Now, we've done these before. It's a group of atoms with a common charge.
Wait, is this the same thing as like polyatomic bonds?
Yeah,
Because I'm getting confused with different titles.
yeah, we're just gonna throw these into multiple bonds. Just because we can.
You can't.
Yeah, we can. Watch, we're getting ready to do it.
How much is this going to take up?
I don't know. I'm gonna do an example of the multiple bond, can I not?
Who's asking?
For the love of God, people. All right. All right, so let's say we have this polyatomic ion, NO plus. And we've got to draw. Break is good.
Yep. I just want at one point in your life you decide what to do this. You know, that you want to Yeah.
I decided I was good at it back in my 20s. I didn't actually want to teach. I just needed a way to pay for school.
This page?
Teaching, yes. I needed a way to pay for school. I didn't have any option. Well, I had very limited
So
options.
what was your goal after college? Like, what did you want to do?
I really had absolutely no idea what I wanted to do, other than I needed a way to pay for school, and there was a scholarship opportunity for people who wanted to go and teach. And I applied, and lo and behold, I got a full ride to school. I got into several schools, and I went to the one that offered me a full ride.
What? No.
And so when I got a teaching scholarship, I had to pick a subject area, and I was like, all right, I was good at this, and I wanted to have something useful when I finished school because I really had no intention of teaching. And, you know, English and history are sort of useless when you get out. And so I was like, well, math and chemistry. I might be able to do something with that when I finish. And then
Every teacher says it.
Right, I think I'm
teaching.
it was not my
Jessup said that he wanted to be a teacher. I don't know anyone who wanted to be a teacher.
No, this subject always wanted to teach.
She made more money.
I want to be a teacher.
No, she was dead serious. She said she made more money being a waitress at Applebee's than she did teaching.
Oh, I believe that.
I believe
That's crazy.
But then she also said, look
Yeah,
where
but
they
she also-
I believe that's crazy. And if you look at where people's starting salaries are and where my salary is right now, I find that highly offensive.
UPS drivers.
I'm at the ceiling, so there's no place for me to go at this point.
I mean, Coach Coleman taught me that UPS.
Quit.
drivers-
I'm 2.5 years from getting my retirement. Absolutely not.
Everyone.
All right. So if you, I don't know. I haven't decided yet. I don't know if I really want to teach. I'd really like to have a job where when I'm done with the day, I just go home and there's nothing to take home with me. I don't have to do any kind of schoolwork or any kind of work. I'm just done.
You could be.
She's already doing that.
Doing what?
Babysit.
Yeah. But, you know, by the time I retire, Shelby will be in college. He'll still be in high school, so I'll still have 3 years of that. So it's not like I'll be an empty nester by that point.
It was bad. Stay with my child's kid.
Well, no, it's not that. I'm not really enjoying middle school. High school, I'm enjoying. Shelby's at a good age. I like high school. But middle school, I just detest. Y'all are awful creatures in middle school.
Yeah, I don't like my sisters just middle school.
Yeah.
I like my
It's,
brother to school to my brother.
no, I just don't like middle school age. I don't like the attitude, the adjustment. I don't like any of it. High school, I like. And y'all have a personality. You're friendly. Middle school, I'd run over and with my car. I'd leave a dent, though. All right. So NO2, NO plus. How do we do this? What do we do with that plus sign? That's what we need to talk about. No. All right. How many N's do we have?
One.
Okay. How many O's do we have? How many electrons in the outer shell of N?
Oh,
How many in O's?
5, 6.
Okay, so we've got 5, we've got 6, gives us 11. Now, you know how y'all are always telling me we're in some kind of weird AP class here. Now, if you're in an AP class, I would let you have an odd number of electrons. But y'all are not. So if you add something up and you get an odd number, bells should start going off in your brains that you did something wrong. Because you are not going to get an odd number in my class. Okay? Huh? Nope. This one right here. What have we learned this right here means to us this semester? Okay. It means you lost 1 electron, right? So right down here, you're going to say -1 because you lost an electron. So that means you have 10 electrons total. If it had a minus sign up there, you know a minus sign means you did what? You gained. So you would do what? You would add. Okay? So we have 10 electrons. So again, I gave you one that's just 2 atoms, so you know you do what with them? Side by side.
Wait,
So,
didn't we talk about like moving all those parts to the left?
so what now?
Picking that one.
Yes, but because these two are like that HCl, there's just 2 atoms. So there's no central atom. There's only 2 atoms. You just put them side by side.
When you say furthest to the left, you mean furthest to the left with
Like on the periodic table. Like if you had, let's say we had a third one. Let's say you had N, O, and F. Okay?
Yeah.
Then you would have to have a central atom. But because and it would be nitrogen. Okay? But since it's just N and O, and there's just 2 of them, there's no central atom. So you just put them side by side. All right? So what's going to happen between them? Okay, so we're going to have a line, and we have 10 electrons, right? So 2, there's 4, there's 6, there's 8, there's 10. Are we okay with 10? Why are we not okay with 10? That's right. O only has 4. So what are we going to do? Okay, so we're going to erase right here and put a line. All right. So that gets O to what? Now let me use a different color. It gets O to 6. So is O okay with 6? No. So we got to do what?
Add one.
Erase and do what?
Add another one.
Add another one. Okay. Everybody good with that? Do we have 10? 2, 4, 6, 8, 10. And does everybody have 8? Okay. Here's the new piece. You put brackets around the polyatomic ion.
That's polyatomic.
Yeah.
If we don't.
-1 or -2, depending on my mood.
I need it for sure.
It's usually -2.
Bye.
It's a minus. This looks fake. Like, it doesn't even look like it makes sense.
You put the wait.
What does that say?
Put brackets around the polyatomic ion.
Okay.
That looks like
that actually.
The I got connected to the C.
I was like, what are you reading?
Oh,
Yeah,
You put the plus right here because
because that's the oxidation number. Yep. All right, you think you could try one? What do you mean no?
Yes.
Yeah.
That's right.
Yes.
Stressful.
It is not stressful. Try that one. Just try one. Try one. Yeah. If you can do it in your head, just do that. Yes. Yeah. If you can do it in your head, once you see it, just do it in your head.
She's over here like, put your thumb. I don't know what's going on.
You better know what's going on by tomorrow.
I'll try. Why do we?
No, we don't have a quiz tomorrow, but you got to be able to draw them to be able to do the geometries. Can't draw them, you can't tell the geometries.
Well, I guess I can't tell the geometry.
Well, it's okay. How many equal opportunity F given?
I'm gonna pray that all
We
the
do
gods,
it.
You're gonna do what?
pray that all the gods there is, whatever religion they're in, all of them.
That's a good plan. One of them's bound to help you.
Hopefully, and what's not like.
No, I might have two.
understandable.
Okay.
Oh.
Got it? Okay, then right away.
I do. That is right.
We get green on over right there.
My bracket's not a box.
Yep. And you don't have to say put in brackets.
I heard you say it scientific.
Okay.
That's it.
Yep. Anybody else?
Oh.
Just quit. No, I got it.
What if it is chemistry? Is it like make medications or something?
Can, and do research.
Oh,
To work in manufacturing.
Wait,
Wait. Okay, all right.
What?
I can't figure out how to do this.
That's because Ken has, 10 on it. 3, 4, 6, 8, 10. Yeah.
I know that.
I know
How many dots you got?
My sister was not
saying
It's so hard.
All right, so how many electrons are there? 24. N's in the middle? 3 O's? 3. All right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 24. Let me fix this line that was supposed to be 2. Now, this is the most common answer I get on the quiz. Right there. Okay? This is the most common answer I get. What do you think people forget all the time? They forget N, and they're like, oh, it's done, Miss Wall. They see those O's, and they go, 8, 8, 8, I'm good. Don't forget N. Make sure you don't. Don't forget your brackets. I don't know how many times I said that, but at least some of you fixed it before I got to you. Okay? Now, put your -1 there to represent your central atom. Now, for homework tonight. Yeah, you got homework. Your homework is to draw Lewis structures.
That's why I did that 6.
If you don't have any homework tomorrow, when I say pull out your homework and find the geometry,
Whoa.
you ain't got anything to practice.
Well, this be great.
Because we're not taking the time to draw Lewis structure to find the geometry. Your homework is what we're using to find the geometries and the polarities.
All of them?
Yes, all of them.
I'm
That
sorry.
depends if I don't fall.
All right?
Here, I'll take one. Oh.
Well, I can't. Too bad. We'll be back up. Put it in there.
All these.
Yes, please.
Do we do all of them?
Yeah.
Yeah, she said only do 1, 2, 3.
All of them.
Yeah, no, I'm just kidding.